Draw a Lewis structure of water. Molecular oxygen and molecular nitrogen are the major components of air, and carbon dioxide is what people breathe out. Looking at the periodic table, hydrogen is in group 1. Therefore, we have 1 valence electron for hydrogen. Since there are 2 hydrogen atoms in water, we multiply by 2. Oxygen is in group 16, 6 valence electrons. Altogether, we have 8 valence electrons. Divide that amount by 2 to get 4 electron pairs. We usually put the least electronegative atom in the middle, but since hydrogen can never be a central atom, oxygen will have to be in the middle. Connect all atoms with single bonds. There are 2 more pairs of electrons remaining to distribute. Put those as lone pairs on oxygen, so that oxygen has an octet. Checking the structure now, hydrogen does in fact have a duet. Since both hydrogen atoms are bonded the same way, we can just analyze one and apply it to the other. And oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So that's good. Oxygen has an octet of electrons. Oxygen is in group 16 and has 6 valence electrons. Multiply that by 2 because we have 2 oxygen atoms. Altogether, there are 12 electrons, 6 electron pairs. Connect the 2 oxygen atoms with a single bond. The single bond uses up 2 electrons. We now have 5 electron pairs to distribute as lone pairs. Just randomly distribute the lone pair so that an oxygen atom has an octet of electrons around it. One oxygen has an octet, but its buddy does not. Let's get the one that has an octet to share with the one that does not. So we take one of those lone pairs and share it as a bonding pair. And check our structure again. This oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So that one has an octet. Since these 2 oxygens are bonded the same way, we can also say that the other one also has 1, 2, 3, 4, 5, 6, 7, 8, also an octet. Notice that the oxygen molecule has a double bond between the 2 atoms. Compared to what we did previously with water, there are only single bonds between each of the atoms. Carbon is in group 14, 4 valence electrons. Oxygen is in group 16, 6 valence electrons. There are 2 oxygen atoms in carbon dioxide. We multiply that by 2. In total, we have 16 electrons, or 8 electron pairs. The least electronegative atom in this case is carbon. We put carbon in the middle, and then put oxygens around it. Form single bonds to connect all the atoms. We used up 2 pairs of electrons, distribute the remaining 6 pairs as lone pairs. Put the lone pairs on each of these atoms so that they each have an octet, until we run out of electron pairs. At this moment, it doesn't really matter how we distribute the electron pairs, but just by habit, I tend to distribute the electron pairs on oxygen because oxygen is electronegative and they like electrons. 1, 2, 3, 4, 5, 6. We used up all 8 electron pairs. And evaluate the structure. Both of these oxygens have an octet, but the carbon in the middle does not. Let's move one of these lone pairs into the bond between carbon and oxygen so that carbon can try to get an octet. The carbon now has 1, 2, 3, 4, 5, 6, so almost an octet. Let's get the other oxygen to share its lone pair with carbon. Now, carbon does in fact have an octet. We can check this work. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. These 2 oxygens are bonded the same way. 2 lone pairs plus a double bond. We have octets for each of these oxygens. This question is slightly tricky. What if we got one oxygen atom to share 2 lone pairs with carbon? Then all 3 atoms would still have an octet of electrons. That is not a favorable molecular structure because of something called formal charge. When drawing Lewis structures, we try to minimize the magnitude of the formal charge. We can try comparing the formal charges in these 2 Lewis structures. Oxygen has 6 valence electrons, minus 1, 2, 3, 4, split the bond, 5, 6. That oxygen atom has a formal charge of 0. That's pretty good. We try to get to 0 as much as possible. This other oxygen is bonded the same way. 6 valence minus 1, 2, 3, 4, split the bond, 5, 6. Also a formal charge of 0. Carbon has 4 valence minus split the bonds, 1, 2, split the bonds, 3, 4. Also 0. This structure is pretty good. We have 0 formal charge for all atoms. Let's look at this other structure. Oxygen has 6 valence minus 1, 2, 3, 4, 5, 6, split the bond, 7, minus 1. Carbon has 4 valence minus split the bond, 1, split the bonds, 2, 3, 4, formal charge of 0. And then this other oxygen, split these bonds 1, 2, 3, and then lone pair 4, 5, plus 1. In this structure, we have non-zero formal charge. There's a -1 and a +1. Even though we have an octet, if we can get to zero formal charge, then that's a better structure. The correct answer is carbon double bonded to each of these two oxygens. Nitrogen is in group 15, 5 valence electrons, and there are 2 nitrogen atoms. Altogether, there are 10 electrons, or 5 electron pairs. Connect the 2 nitrogen atoms with a single bond, and then distribute the remaining electrons as lone pairs around either of those 2 nitrogen atoms so that they have an octet, until we run out of electrons. This nitrogen has a lot of electrons, but this one does not. Get the one with more electrons to share with the one that has less. Move one of the lone pairs to become a bonding pair. That's better. The one that has fewer electrons still has fewer electrons, not quite an octet. Let's get the one that has more to share another pair of electrons. And check the structure. The nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Both nitrogens are bonded the same way, triple bond with a lone pair, so both of them have an octet. We can also check the formal charge. Nitrogen has 5 valence, subtract 1, 2, split the bonds, 3, 4, 5. This nitrogen and the other nitrogen both have a formal charge of 0. This example as a whole shows how single bonds, double bonds, and triple bonds can occur in molecules. The nitrogen molecule has a triple bond, whereas oxygen has a double bond, carbon dioxide has 2 double bonds, and water has 2 single bonds. Despite the differences in bond order, the atoms have octets, duets for hydrogens, and 0 formal charge. When drawing Lewis structures, put the least electronegative atom in the middle, and then connect all atoms with single bonds. Distribute the remaining electrons as lone pairs around all of the atoms to try to get them to an octet until the electrons run out. And then move the lone pairs to become bonding pairs so that the atoms have an octet. The atoms C, N, O, and F, which is not shown here, all need an octet. Hydrogen is a weird one. Hydrogen cannot be a central atom, and hydrogen only takes a duet, 2 electrons, not an octet. And also consider formal charge. Try to get the formal charge as close to 0 as possible for all of the atoms in the molecule.